hope you are all doing great and enjoying this series on vector calculus. In today's lecture, we are going to talk about Frenet-Serret formulas. So, we have already actually seen these formulas, but we didn't name them earlier. We'll nicely put in a nice form, in a matrix form, these formulas. So, what are Frenet-Serret formulas? So, we know that when we are studying a curve, right, in space, we saw that at every point there is an intrinsic coordinate system, which is t unit vector, n normal vector, and then binormal vector b. And we also saw dt by ds is curvature times n vector, and we also claimed, and we have not proved it yet, that dB by ds equal to minus, this was torsion times n vector, right? And there is something about dn by ds also. We'll prove this thing, that this is equal to minus kappa times t vector plus tau times b vector. Okay. So, these are the formulas we have, okay, and we have till now just proved this formula. We still have to prove these two formulas. So, these formulas, we will be proving these two formulas in today's videos. These formulas are known as Frenet-Serret formulas. Okay, so these are behind, like, on the name of two different mathematicians, Frenet. This was Jean Frenet, and this was Joseph Serret. They published their formulas in 1852 and 1851, right? Separately they published their formulas. So that is why we call them as Frenet-Serret formulas. And it is convenient to write this set of formulas as in matrix form, because that way we can remember it. So this is T prime, B prime, N prime, sorry, T and B, T prime, N prime, I am sorry, here it is n. Okay, here it was b, you are right. Okay, but we'll write t prime, n prime, and b prime, because we treat t, n, and b as our system, right? Right-handed system. So we write it like this. So this is equal to, if I want to write it as a multiplication of a matrix with the vector t and b. So what is here in the first row? We know that there is coefficient of n only, so 0, kappa 0, and then in the second row it would be minus kappa and tau. So this will be minus kappa 0 and tau, and in the third row it will be 0 minus tau 0. So now you can see that if you multiply first column and first row and first column, you will get the first formula here, and then if you multiply the second row column and first row, you will get this second formula here, this formula here with respect to n, and then you go for third row and first column, you will get this formula, right. So these are Frenet-Serret formulas which you have to remember. Now let us prove this formula and this formula, right. Okay. So I want to prove that dB by ds is equal to minus tau n vector, right. For that, what I do, I say that dB by ds is a vector I know, and t and b is a coordinate system, right. And if I break my matrix into along these coordinate axes, so I will get some constant as times t vector plus bs times n vector plus cs time b vector, right. And if I want to find out a of s, that would be dB by ds times a dot product with t vector, because if I take dot product with t vector here, 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 and here, then these and this term will be 0. So, and this is 1. So, I will get a of s is equal to this. Similarly, b of s is equal to dB by ds times n vector, and then c of s is dB by ds times dot product with b vector. Okay. So, now let us calculate as, bs, and cs. So for that, if you calculate, we know that b dot b is 1, therefore derivative of b dot b is derivative of 1, which is 0. So I can write it as b dot db by ds plus db by ds dot b equal to 0. So I get 2 b vector dot db by ds equal to 0. So that gives us b vector dot db by ds equal to 0. So this is 0. So therefore we get Cs is 0. C of S is 0. Right? Okay, great. Now let us work on B of S or A of S. Right? So if we want to calculate A of S, for that, I'll use this information that B dot T is 0 because B and T are perpendicular. So B of S is dB by ds dot product with n vector, right? Okay. So here I am calculating A. So this dB by ds dot product with T vector. So if I differentiate it with respect to S, so I am going to get dB by ds dot product with T vector plus dt by ds dot product with B vector equal to 0. So we get dB by ds dot product with T vector equal to minus B vector dot product with dt by ds. So this is nothing but A of S. Can you see here? This is A of S, right? This thing and this thing. So we get that. So we get that A of S is minus B times dt by ds. Now what is dt by ds? Dt by ds was your excuse me, curvature times n vector. So this is equal to curvature b dot n vector. So what is b dot n vector? That is 0. So therefore we get 0. So A of S is also 0. So you are left with dB by ds equal to B of S n component. Okay, there is no further reduction possible. We assume that B of S is minus tau, therefore we get dB by ds is equal to minus tau n vector, where tau is torsion of the curve. Torsion means how much three-dimensional your curve is. Okay, great. Now we want to prove that our dn by ds vector is minus kappa times t vector plus tau times b vector. So it's also on the same lines. We'll assume that dn by ds has components along t, n and b as A of S and B of S and C of S, right? So you'll get, now I want to calculate A of S. So A of S would be dn by ds dot product with t vector. B of S would be dn by ds dot product with n vector, and C of S would be dn by ds dot product with b vector, right? So now if you work on A of S is dn by ds dot product with t vector. So now you know that n dot t is 0 because they are perpendicular. Therefore, dy by ds of n dot t is 0. Therefore, dn by ds dot product with t vector plus n vector dot product with dt by ds is 0. So that means dn by ds dot product with t vector is minus n vector dot product with dt by ds vector. So I can write this quantity equal to minus n vector dt by ds. Now what is dt by ds? Dt by ds is your kappa, right? So this is minus kappa times, this is your okay, this was dot product, right? So this is n vector dot product with kappa times n vector. So this is minus kappa n dot n, and n dot n is 1. So this is minus kappa. So we got the value of AS as minus kappa. Now let us work on B of S. B of S is dn by ds dot product with n vector. This is 0. Why? Because n dot n is 0, 1, because they are same vectors. So if I differentiate n dot n, I should get a 0. So that means dn by ds dot product with n vector plus n vector dot product with dn by ds is 0. So that means 2 times dn by ds dot product with n vector is 0. So that means dn by ds dot product with n vector is 0. So this is 0. So we got B of S here, this quantity is 0, right. Now let us work on C of S. C of S is going to be dn by ds dot product with b vector. So you have dn by ds dot product with b vector. So again we use the same information that n dot b is 0 because these two are perpendicular vectors. You will get dy by ds of n dot b is 0. So that gives us dn by ds dot product with b vector plus n vector dot product with db by ds is 0. So that gives us dn by ds dot product with b vector is equal to minus n db by ds. So now this will be equal to minus n db by ds, right. So because you just proved that this quantity here is equal to this quantity, right. So that will be equal to, now in place of dB by ds, I am going to put minus tau times n vector, right. So that will be equal to minus tau plus minus minus will become a plus, n dot n is 1, so you will get tau. So this quantity here is tau. This quantity here is tau. Therefore, we get dn by ds is equal to minus kappa t vector plus tau b vector, right. So finally, we can again rewrite our this Frenet-Serret formulas. So you have dt by ds is equal to kappa times n vector. Then you have dn by ds equal to minus kappa times t vector plus tau times b vector, and then you have dB by ds is equal to minus tau times n vector. So these are our Frenet-Serret formulas. So I hope you understood. If you have any doubts, please write in the comment box, and please share this video and subscribe to this channel. Thank you for watching and keep supporting.